Right, grade 12. So we are back with some quick math. We are proving the proportionality theorem. What is the proportionality theorem? It tells us that in our triangle above, if these lines are parallel, right, then it will tell us that AB divided by BD would equal to AC divided by CE. Okay, on our picture, what does it mean? It means the side divided by the side would equal to the side divided by the side. Okay, so that's what our proportionality theorem tells us. How do we do the proof? Okay, we do the proof like this. The first thing we're going to do is to draw in a construction. We are going to draw in a construction from line C, from point C rather, to line AB. And that construction that we've drawn in has to be perpendicular to line AB. And we can call it, let's go and call this line H. Okay, so that line is called H. The first thing we're going to do in proving the proportionality theorem is to find the area of this triangle above. Okay, so we want to find the area of a triangle. How do you find the area of a triangle? So area of any triangle is equal to half base times your perpendicular height. Okay, half base times your perpendicular height. So what is your base and what is your perpendicular height? Well, the perpendicular height is given to us, but what is our base? Our base is not the bottom as we might think. Our base is dependent on where the perpendicular height is, where the 90 degrees is. So if this is the 90, then the side where the 90 falls on is our base. Okay, so for triangle ABC, the base, the B that you're going to use is going to be line AB because it's your base of that triangle. How do you decide where your base is? Where your 90 degrees falls, that's your base. Your perpendicular height, that's the H that we've named over there. Okay, so when we do our proof, the first thing we're going to do is we're going to say area of triangle ABC. And we know that that area is a half times your base, which is going to be AB for us, times our perpendicular height, and we chose to name it H. Okay, let's go look back at our picture. That's the first part that we're going to include. The next part is we're doing another construction. This time the construction is going to go from point C all the way to point D. And in doing that construction, so those lines that you see there are lines you're going to draw in. I'm going to draw another line in green, or I'm going to show us some things in green. But what I'm showing you now is not going to be drawn in on your construction. I'm just showing you this so we can see something. So the next triangle that I'm going to look at is triangle BCD. So this is the triangle that I'm looking at. Okay. However, if I extend this line of that triangle, okay, if I extend this line on that triangle, then I can see that this H that I had earlier is also the perpendicular height of this triangle BDC. Okay, so this height, which is H, is also the perpendicular height of the green triangle that you see. Okay, let's get rid of the green stuff. So now what I'm going to write is this. I'm going to say the area of triangle. What was the triangle at the bottom? BDC. BDC is equal to half. Now my base, okay, again, how do I decide the base? So if this is the triangle that I have, and we're saying that H is your perpendicular height of that triangle, of this triangle, then your base of your triangle would be this line, which when once extended generates your or creates your perpendicular height. Okay, so this line BD is also the base of the triangle which has the perpendicular height H. Okay, let's get rid of all of those green things there. Right, so now it's half, so your base is going to be the BD, and your perpendicular height is still the same thing. Okay, now we're going to divide those two with each other. So let me just erase these equal signs over here that I had, and I'm going to put it over there. So I'm finding the area of ABC, and then I'm finding the area of BDC. Let's look back at this. We found the area of this top one, and then we found the area of this one, which we've constructed. They share a perpendicular height. Both of them have that same perpendicular height. Okay, let's look at what we have. So now we can see some nice things. Your halves cancel out, your perpendicular heights cancel out. So you are only left with AB divided by BD. Right, let's go look at our proportionality theorem again. This is the proportionality theorem, and what we can see is that we have this left half. Okay, we're halfway there. Now we're going to go back to our triangle, and we're going to do some more constructions. Maybe I'm going to put this one in red. So this is also a construction that you are going to draw. You're also drawing this in. Okay, you are going to draw a perpendicular height again, this time from B to AC. So B to AC, there's another perpendicular height that is going to be drawn, and let's call this one K. Right, now I'm going to look at, let's make it green again. Now I'm going to look at triangle ABC, and now I'm going to use K as my perpendicular height. That means AC is now my base. Base is dependent on where your perpendicular height is. Great. All right, so now we are going to say that the area, again, the area of triangle ABC, and we now figure out that it is half. Base, what was our base? Our base is the AC this time. And if AC is the base, then our K is our perpendicular height. Okay, and now we're going to look at the bottom. Same thing that we did at the bottom, we're going to do on the other side. So we are going to draw in a construction line from B to E. And because of that construction line, this triangle is created, BCE. That triangle is created, BCE. Now, when BCE is created, if this line over here, CE, is extended, then we see that K is also our perpendicular height of this green triangle that we have over there. Okay, so we are seeing that the green triangle also has K as a perpendicular height, and if K is the perpendicular height, then CE is going to be our base. So now what we are going to say, let's get our pen back. We are going to say triangle BCE, the area of that triangle. BCE is equal to, again, half. Our base, we said, was the CE, and they share perpendicular height, which is again going to be the K. Right, same like we did in the last one, we are going to divide these two things together. So let me get rid of these equal signs. There should only then be one. Okay, so now again we can see your halves cancel out, your K's cancel out. So what we are left with is we are solely left with a C divided by CE. If we go look back, that is the right hand side of our theorem. Okay, we're almost there. Okay, so take a note of what we have written before. So far we've said the area of ABC, okay, what's going on there? Area of ABC is equal to half AB times H. We said the area of H, or not H, the area of BDC is half BD times H. We divided those two together, and that gave us the left-hand side of our ratio. Similarly, we said the area of ABC divided by the area of BCE, and that gave us the right-hand side of our ratio. Okay, the construction looks like that. So all of the things that are drawn on that triangle is what you need to be able to draw in. Also, we are making a reference to K and H, so make sure that that is shown also on your diagram. Great, so we're almost done. Let's look at this, and I'm going to put it in green for us. Let's look at this triangle, and I'm going to keep it in green, this triangle over here. So those two triangles, okay? So I'm just gonna, let's see if I can do this. I'm gonna extend this line on both sides. And if I extend that line on both sides, what I have is this height that's created over here and this height that's created over here. Those will be my perpendicular height if I choose BC as my base. Okay, so what I'm saying is, maybe let's put it in black again. This length here and this length, they are the same thing. They're equal to each other. Why are they equal to each other? Because those lines are parallel, right? So those lines are equal to each other. What does that mean? That means if BC is my base, then those two green triangles that I've drawn at the bottom, they share a base and they have the same perpendicular height. They share a base and they have the same perpendicular height, right? Because they share a base and because they have the same perpendicular height, the area of those two triangles are equal. Okay, so now what we're going to say is we're going to make this statement. We're going to say the area of triangle, let's see, it was BDC. BDC is equal to the area of triangle. All right, let's just fix that. Not triangle, area of triangle BCE. Okay, so why is this important? I'm basically saying that this one and this one, the stuff that's at the bottom, are equal to each other. That's what this line means. All right, so now we can say therefore. Okay, so therefore, this one over here and this one over here are equal to each other. Okay, so we're gonna say therefore triangle or area of triangle ABC. Okay, gonna just rewrite this. Let's just write that again. Okay, nice, fast to see, very nicely. Area triangle ABC divided by area of triangle BDC is equal to area of triangle ABC divided by area of triangle BCE. Okay, so what did we say? We said, let's get rid of that. This one equals this one. That's what we're saying. And what is this one? That one is that. What is this one? That one is that. So now we'll say therefore AB divided by BD is equal to AC divided by CE. Right, so let me zoom out. That is your proof. Okay, that you see there, that's your proof. That is your construction. Make sure that this is one of the ones you know off by heart.